Yay! All right, we have fixed our technical difficulties. So check us out, taliproject.org and github.com/taliproject, and you'll find all of our work there. So, like I said, the previous talk was awesome. We're doing it in real life at Microsoft. It's all completely open source. So today, I'm going to digress just a little bit, and we're going to talk about asynchronous JavaScript at Netflix. I, of course, am very unoriginal in my name, Matthew Podwysowski, and of course, yes, that is my Twitter handle, and yes, also my GitHub handle. So really what it was async programming in JavaScript. But what really I like this to be is how I stopped worrying about asynchronous programming and love to learn the observable. So, you know, I could go like this and write a bomb, woohoo, but I'm not going to. Next. Anyways, slides also started out with a little bit of levity. I thought I had a problem, so I thought to myself, you know, I'll solve my problem with promises and events. Have now two problems I. Oops. So what this is not going to be, it's not going to be if you've seen my former boss, Eric Meyer, he usually talks about monads, category theory, and so forth. There will be none of that, although if you're really interested, I mean, a monad really is just a monoid in the category of endofunctors. I mean, really, what's the problem? What's the deal here? It should be rather simple for you to understand that, yes? So here I am. Like I said, I'm a principal SDE at Microsoft, that small company. Everything that I do at the company is open source. So whether it's the Tali project or the reactive extensions, which I'm talking about today, you can find me here and everywhere pretty much using that same handle. And yes, I do work for this small company called Microsoft, but I think just because I'm working with a lot of open source that I add a little bit of metal to it by adding umlauts, because that just kind of rocks. Anyways, so, you know, we recently announced this browser called Edge as well, but, you know, some people thought it was the U2 guitarist, but no, it was based upon me. So I'm just a little humble brag there. But the problem is I found that I'm not as good of a songwriter because JavaScript has thoroughly corrupted my mind. So if I said you and me makes 2.00004 crap. Yes, thanks, JavaScript. So I work on a project almost full-time called the Reactive Extensions, and this is a language-neutral approach to asynchronous and event-based programming across a number of languages. And if you go to that website, if you have internet connectivity, you can go there, check us out. You'll have a lot of documentation and a lot of various cool things to check out. So if we go here to reactivex.io, sure enough, you can choose your platform, but you can go down there and see all of the things that Andre was talking about in terms of these marble diagrams, and you can basically see how you can get started with Ajax. So it's really kind of a cool project, and we've really made sure that it's really cross-platform. But what I'm really saying is I'm an RX pusher. I like to say it belongs everywhere. So let's bring it back to actually the main topic here, is Netflix. So Netflix is a company that streams movies and TV shows from any device. And what it accounts for is 1/3 of all US broadband traffic. And that's just as of a year ago. It could be more now. But they had some really, really big problems that they had to solve in order to fix this. Because they had some really basic really basic problems, and they had them across different languages. But they thought differently about events and asynchronous programming so that they could create these very rich interactive user interfaces. So if anyone has the Netflix app on your phone, chances are you're running our software. Everything about that application, as Andre so eloquently put, everything about these applications is asynchronous, whether it's your app startup, the player, the data access, the animations, the view model bindings, all of that is very, very asynchronous. But it also leads to a number of nightmares just because you're dealing with asynchronous programming. You're dealing with possible memory leaks with event handlers leaking. You have race conditions, whether callbacks happen or events happen at a certain time. You have this thing called callback hell, which I'll get into. But really, you have these complex state machines where the state is just sprinkled throughout all of your code, as well as the error handling itself is all just very disjointed, and it's really hard to find out where the actual logic for your application is versus everything else. So if we go back a couple of years, they started with I would say about 4 or 5 different platforms. And what was bad about this is because each and every language had its own real way of talking about asynchronous stuff. They had a back end using Java. They didn't know how to really scale that out. You had the user interfaces very tightly coupled in terms of the client and the server were very, very connected. There was no real clean abstraction for how they do that. So what they decided to do is they decided to adopt RX. Now we have a problem in today's world, and that problem is that we are just inundated with data. Whether it's your phone, when you have, when you have your Twitter app, you have any number of apps. You have at least 6 or 7 different things. Whether it's your accelerometer, your GPS, etc. Everything's firing at you. None of it's really pool-based. So how do you manage it all without having to stuff it down your shirt? Is a really interesting problem. But the problem has always been is that asynchronous programming is just plain awful. As you can see, we're managing all sorts of states, and then once we actually try to do an action, it just immediately falls over. That's pretty much it. So we had a very progressive president back in the day, and he decided in 1962, he was going to say, we choose to solve asynchronous programming and do other things, not because they're easy, but because they are hard. Now, he later changed this to actually going to the moon. And the reason why that is because he actually thought going to the moon was possible. Not asynchronous programming. So that wasn't solved in the 1960s, and apparently, citation needed, oh well. So callback hell really is a thing. You know, many people say, "Oh no, you've just designed your application wrong." Well, no, that's not really true. What it is you're dealing with these very complex state machines. Whether there's a player error, whether you've got a ticket, and so it's really hard to kind of follow where your code is going in terms of what's the next step. And with retries and everything else, it's really, really nasty stuff. And most people, call it the Temple of Doom or something like that, but I equate it to a cow's head because it just walks off the screen like that and walks right back. And I don't know about you, but usually you're playing with fire when you're dealing with callback hell. And so anyways, and yes, I do happen to jump out the window sometimes so when I'm dealing with that. But dealing with events is just as awful. The idea of having just a simple drag and drop has a lot of boilerplate code to it. Whether the mouse is down, whether the mouse is up, what sort of state do you have in between there. You have to add the event listeners and then you have to remove them. And you just end up with just so much state passed throughout the application. So, like I said, it gets very, very complicated very quickly because you're trying to manage all of these different moving pieces at once, and it never quite works out the way you think it should. So everyone goes, "Ooh, yes, promises. Promises will solve all of our problems." Promises are coming in, ES6, ES25, whatever you want to call it. The idea that you could say player initialize, then authorize the movie, else you've got a login error, and play the movie, or else it's unauthorized. That's just peachy. The problem is that we have several problems with this very approach because promises lack a fundamental thing that's required for doing anything I/O related, and that is Cancel. There is no such thing. So if you're doing something like an autocomplete with a promise, you're like, I'm continuing to type, and this promise is hanging out here, and it's going to eventually return. How do I tell it not to? Well, I can't. Not the way that promises are currently designed in ES6/ES25, 2015. So that's a problem. And in fact, it became so much of a problem in that they introduced this fetch API for the next version of the browser. So and what it turned out to be is, yes, cancel became the #1 issue. And as you can see here, there are 182 comments on how people are trying to cancel a promise. So I guess that answers the question of how many engineers does it take to cancel a promise. So as I said, you can check it out yourself, GitHub, Whatwig, issues 27. I'm sure there's more ideas and more things there. And like I said, it's been an awkward issue for a number of promises libraries that they can't quite figure out how to do cancellation properly. And once again, you have the issue as well is the fact that there's no such thing as finally either in promises. Oops. So there's no way of finally cleaning up after you're done and disposing of your resources. So as I said, you've got a nice car, you've got a nice gas pedal, you've got some nice cup holders, but you forgot brakes. It happens. So unsafe at any speed. So when people started to say, well, what about stream processing? Why couldn't we just use some of the ideas from, say, node streams, for example? Well, let's face it right now. If you used Node way back when, you'll realize that streams are really terrible. I mean, the pause data started immediately, whether you were ready or not, poor kid. And pause and resume were really impossible to get right. I mean, there were geniuses out there such as Substack and Dominic Tarr who did a lot of stuff, but fundamentally the core was rotten and broken. And then they changed to Streams 2 and Streams 3, but still, it's not quite a perfect fit for doing a lot of this event-based processing that we're trying to talk about here. So instead, we took a different approach and went back to 1994. And we went to this book called Design Patterns. I don't know how many people still have it, how many people were born before then, whatever. But we had a lot of patterns here. But what you saw is a lot of these different things are all connected to one another, except these two, which was kind of strange. We were like, iterator and observer should be kind of connected. And the reason why is because we have the idea of a push-based collection and a pull-based collection. So with ES 2015, we have the idea of first-class iterators, or we call .next, and then we can go through and get all the values as they come through. And the same thing applies, the subject-observer pattern as strictly implemented in JavaScript. It happens all over the place with the DOM. Anytime you add an event listener, that's really just the subject-observer pattern. So anytime I move the mouse, yay, I get values pushed at me. So it's a pull versus push kind of collection. So let me ask you a question then. What's the difference between an array and an event? And they're both collections. And that's really the key part here. And what we can do is we can write the majority of Netflix's code with just a few flexible functions. So as Andre talked about before with map, the idea of transforming each individual item, to filter items emitted by a collection, to kind of merging them all into a single one, and then flat map, which is basically that map and merge all into a single collection. So now we can actually take a look and see inside of Netflix how they would get your top-rated movies. Well, you would start with a given user, and you would look over their video list, and you would map with their video list, and you would go through and filter where the rating is top 5, and you would merge them all. Or you could just go call flat map and be done with it. Now, what if I told you that same code that we showed here, you could create a drag event? It's really kind of that simple. And the fact is, instead of filter, we have take until. So we have take until DOM mouse move up. or just flat map. So let's take a look at this again. Flat map filter, flat map take until. That's it. You now suddenly are all reactive extensions programmers. Done. And what you realize is that, oh great, everything's a stream. My mouse is a stream. My phone's input is a stream. Everything's a stream. And it's kind of a Zen-like moment when you kind of realize that. Because now instead of these callbacks that you had to deal with before with the subject-observer pattern, we now have a first-class object. And that first-class object that we were talking about are the things that we can filter and reduce, etc. But we can also inject into methods, and we can return them from methods, which is great for testing and any number of things. Now, where does it fit in the world? Well, with the world, we have synchronous and asynchronous with multiple value and single value. So obviously for synchronous and single value, we have object, and then we have an array for multiple values. Then we have a promise, which, like I said, you can do then, but here, the observable, you will see the exact same code applies from array to observable. No changes, other than the fact that it happens to be an observable source. So people keep asking, well, what is this buzzword about reactive programming? Because everyone sees React, whatever. It's such an overloaded term now. And so people are saying, well, what is React? Well, the dictionary just says readily responds to a stimulus. Okay. Not really all that useful, is it? So basically active and ready to respond to events. You know what? Just go to this paper and just read that instead. bit.ly/reactive paper. I know people are kind of averse to reading papers like this, and this is their general reaction. But I guarantee you, it's well worth your time if you do that. Now, functional reactive programming is something that people talk about quite often, and they're like, ooh, FRP. And I was like, well, we're not FRP. Because FRP is a very specific term for continuous time, behaviors over time, the idea of basically having a continuous cycle. JavaScript, you can't really do that. It's a single-threaded environment. You have callbacks, etc. So it's really not FRP at all. It's not just adding map, filter, and reduce onto events. So just call us whatever. I mean, call us compositional event processing if you're not into the whole brevity thing, And like I said, between the push and the pull world, there is no difference. Filter, map, for each, filter, map, for each. All of those are exactly the same. So let's actually talk about the creation. What exactly is an observable? Well, let's actually talk about that real quickly, because this is why it's very, very interesting. So for example, if we wanted to create something like from event, we would have some sort of element, an event. We would have some sort of handler, which would call next with our given value. Then we would hook that up to add event listener with our handler. And then afterwards, we would create this little teardown function. And that's really great when you're dealing with a lot of events as you're composing them together. And if you want to unsubscribe with take until or anything like that, then that automatically removes the handler. You don't have to do that yourself. So Netflix search, we could do autocomplete basically with the same kind of code, where you can take the key ups, we can get the value, we can debounce it, so maybe we're typing too fast and we don't want to send all of that to the server at once. We can get the latest term. So when we're dealing with asynchronous program, there's the idea of you getting out of order responses. With flat map latest, that's not possible. We cancel the previous request, and then only the current request is valid. So that's pretty cool, and the fact that then we can call for each and then bind it directly to the UI with our data. So what Rx is just three basic concepts: the observer and the observable, which we've kind of covered a little bit. And we have the idea of on next, on error, and on completed, where we can have an infinite value, a couple values, and an error, a couple values and an end, but you can't have overlapped values, and you can't have things that happen after the fact. And so we had that map, filter, and reduce that we talked about earlier, but how do we actually use it in something usable, you know? So what we could do is we could poll for client updates. So that's a really kind of a cool problem to have, don't you think? Is that what you can do is that you can make sure that what you're doing is very responsive. So here we're going to listen for the document scrolling. So as something is on your hardware-constrained device, and you want to make sure that you only keep in memory what's on the screen, nothing more, nothing less. So in order to do that, we have to first listen to the scroll event. And then we have to start debouncing, so allowing people to scroll up, scroll down very nicely. And then what we can do is we can then further divide that into whether it's visible or not. And then we can combine this all together with a kind of an interval, so we're constantly listening and taking that row data until it's hidden. And when it's hidden, it's gone. So this is kind of some Netflix code that they actually use today in terms of how they handle a lot of this complex user interface design. And the player itself, like I said, you could design it with callback hell, which is what they originally had, which ended up with this cowhead. But instead with observables, we have a very, very simple approach to that. And that is we can initialize, flat map, play attempts, then we can authorize, retry 3 times, and take until cancel. Something that we couldn't easily do with that callback hell version, which is that if someone hits that cancel button, it will actually stop the whole transaction from going through. That's cool, because now we have the ability to kind of merge together all of these different events into one. And they also had another set of problems is how do they deal with errors and so forth with WebSockets? Well, we have an idea of Netflix has created WebSocket subject where they can hand it multiple endpoints and it keeps failing over till it actually gets something. But that's kind of cool too, in the fact that you can listen and you can decide when to send data and so forth. And yes, you can do try, catch, finally. So for example, one person was asking about handling errors. Well, here we can say .catch. And so for example, if you're in a constrained environment where things such as offline matters, you can get some default data and put it in there. And then you can finally do some cleanup, and then you can process each item as it comes through. Now, the role of schedulers is kind of our secret sauce and what really kind of puts us apart. And it really is where do I run these values and how? So we have this idea of many different ways about handling schedulers in such a way that we can schedule some work and we can also cancel it at any time. So all of that cancellation that I talked about goes all the way to the very core of what we do. And it provides some testing benefits. For Angular, you could fit it into the digest cycle. For any number of things, you can also choose a very specific implementation. And of course, you can do some deterministic testing, such as JSConf BP 2015 happens at these particular times, and we can always determine, that it happened then. So there's no callbacks, there's nothing in terms of when you're testing observables, it just works. Now, schedulers do matter. So for example, if we're taking something like we want to draw something on a screen, well, if we take the default scheduler, the problem is going to be it's going to eat up our CPU. I mean, it will, if my fan weren't going, it would probably levitate just because the fan was going so hard, is because it's just drawing every single time as fast as it can through the fastest available means on your platform. But instead, what we could do is we can swap that out. And suddenly we can say request animation frame scheduler. And now it looks actually sane. And guess what? Your computer is not going to levitate anymore because just because that it happens to eat up a lot of resources. We have back pressure as well. It's not super, super important, but for a lot of people that are concerned about how much traffic they get, we have pause and resume capabilities. And async await, given the fact that it's coming to JavaScript vNext, whatever that is, ES7, ES 2016, whatever you want to call it, the idea of async and await is coming in some form or fashion. But you can already do that today with the spawn function inside of Rx, where you can do the retry, catch, and finally all of that, and then log the result. We have that today, so you're living in the future already. And then what we're working on now is we're working on the idea of taking observables and moving it into ES7 directly. So the fact of now you can get your mouse drags and your mouse moves and take until mouse ups, all completely native to your browser. If you want to learn how to do this, we have a great tutorial out there, jhussein.github.io/learnrx. All of this is on our site. RX Marbles, a great site by Andre, is also a great way to learn how each individual operator works. And if you really want to see how something complex is designed, there is a Sweet.js, and it's an idea of a macro-based language, but all of the bits and pieces of the editor itself is all in Rx. And that's handling all of the state, all of your initial settings, and so forth. So I'll leave you with this before we dive into some demos, but what I really want you to remember is push. Oh dear, why are you, oh, okay. Are you not going to, well, let's see if it plays. Apparently the gods are not smiling upon me today in terms of actual audio. So I will go directly to, you come see me afterwards and we'll play it together. It'll be great, I guarantee you. So if you go to our website, like I said, we have a lot of material here. We have our design guidelines, we have our recipes, our unit tests. We have all of these ways people are using it with React today. Using it instead of Flux, I think my favorite one is thundercats.js. Just because of the name is kind of cool. And you can do some really kind of cool things. You like interactions here in using Rx and React together. You can also do autocomplete, obviously, if you have great internet. But you can also do things like game programming. So, for example, all of this thing where Mario is jumping and so forth and moving about all has to deal with keyboard events, gravity, and all of these other things that you can just kind of merge together. And like I said, since it is such a thing with game programming, is the fact that you can play games to your heart's content, because what you're dealing with is you're dealing with timers, you're dealing with bounds checks, you're dealing with keyboard events, and so forth. And so, as you can see, we lost, it hit that bounds check, and so forth. And like I said, great for animation, great for those sorts of things. And let's see, there we are. We can also play Pac-Man, so if you're so inclined to play Pac-Man in JavaScript, yay, you can do it. We can also do a very complex user interfaces, such as coordinating all of our event handlers together. We can paint on a canvas, so I can start taking different colors. All of these are in our samples today. You can take a look at them, they're all there. And this is, like I said, the request animation frame scheduler. And as you can see, my machine is not lifting off of its moorings here. Now, one other cool project is, how do I actually visualize what I'm doing here? So, for example, if we had some code here where we take from event and we do some mapping and subscribe to it, what does it look like? Yes, we've got some output here, but down below physically tells us exactly what happened in terms of creation of events, mapping, and subscription of each one, and when it happened. Really, really kind of cool stuff. In addition to the work that Andres did with Cycle, there's also WebRx. There's great stuff, and as well as Cycle, which Andre has so done. So I will wrap things up here with that. And so thank you very much.
I think we could get a tan in this light. At least I could. I have one question from Twitter, and I just love this question. I don't know how to even read it without laughing. The star's color on your hat, gold or blue, #DressGate.
Oh, good Lord. So they are some are blue, some are gold, and some are silver. So yes.
Problem solved.
Yes.
Whoever asked that question. I didn't see anything else on Twitter. So
God, I must have been boring or something.
I don't know. Or the hat was just so amazing that everyone was so distracted they weren't even listening.
This is very, very possible. So, I mean, like I said, it's funny because I've been working on this particular project for 5 years now, and what we're seeing is kind of mass adoption through GitHub, through Slack, through Netflix, and even Microsoft. So if you're using like Microsoft Online, all of that uses RX. So it's kind of interesting just to see over time how kind of things have just radically changed, and people are finally accepting the idea 5 years after the fact. Because we presented this back at JSConf 2010, and whoosh, went over most people's heads. Pardon me.
Questions? Didn't see anyone. Oh, there's a question over there.
Yay,
2 questions. Raise your hands. I knew there were questions. They were just hiding, or they were just so an A, or so impressed by your hat that just couldn't.
I could have worn my RobotsConf hat. I don't know if that would have been less distracting.
Kind of a general question.
Sure.
First of all, does RX play well with Angular, or is it a lot more focused, or works a lot better with React?
That's a good question. So one slide I kind of cut at the last moment, but it really does play well with the libraries that you use. So for example, we have rx.angular.js, which basically does a lot of the bridging to and from Angular directly. So for example, if you want to do certain things within the digest cycle, we have kind of helper methods to do all of that. React, everyone is doing stuff with it, but there are a lot of projects like RX React and so forth, as well as RX Ember and RX jQuery, all of those sorts of things. So it blends very, very well. You don't have to throw out everything that you've ever done. You can continue to use it just the way that's kind of mixing it in and into your current project.
One other thing I didn't quite understand regarding the promises. Does it somehow play in with it, or are they completely separate concepts that don't work together?
Well, they are separate concepts, but no, we do play very well with promises in the fact that things like the flat map operator that we showed up there, merge and many others actually accept promises and will convert them automatically to observables for you. So just because you could call jQuery or Angular and get back a promise, it binds directly. You don't have to do any special magic or voodoo yourself. And what's kind of interesting, you mentioned Angular earlier. What they're doing for all of their I/O going forward in Angular 2, they have adopted observables as part of what they're doing. So that you'll be able to use .subscribe and all of the other filters and maps and so forth that I showed you here.
Okay, thanks a lot.
There was another question over there.
Yeah, over there.
Now we need to go all the way around.
Exactly.
Just jump through people.
Just crawl over people. It doesn't matter, right?
Hiya.
Hello.
So I've been playing with it a bit.
Okay.
What's the best way? So when you've got an observable and a stream of functions, what's the best way to debug it?
Debugging. Well, there are many ways about doing that. We actually have that in our documentation. But debugging, you can either put breakpoints in each of your function callbacks for map, filter, and so on. But we also have this notion of do or tap, where it captures each individual value as it comes through. So here it's this, here it's that, and then you can do a lot of what I call caveman debugging, where you're just calling console.log everywhere. But that's not really scalable in terms of getting the right answer in terms of where your program failed. So we have this notion of long stack traces, and the idea behind that is we eliminate all of the RX code and all of the browser code and only keep it down to your code as to keeping the stack from that. So if it fails during a map or a filter or something, we'll immediately have that in the air stack, and we won't report anything that RX did.
Okay.
So that's really kind of good for debugging purposes as well.
Cool, thanks.
I think the caveman debugging is going in history now, like people are going to
Yeah,
actually use it.
yeah, exactly. Yeah.
Can you use the special technique, caveman debugging, like that's what we're rolling with right now?
Exactly, caveman debugging. Let's go old school like that.
It's very agile.
No, absolutely. All you have to do is just do a control replace and get rid of all your console.logs afterwards.
Oh my God. Okay, one more question.
Yeah, hello. Is these ideas good to implement also in Node.js on server side, handling requests?
Oh, absolutely. In fact, one of the examples that we have a couple of examples using it on a Tesla, but we also have it working on Node. So, for example, at Netflix, they use RX in Node. We have a little stock example where we take a stock feed and start doing analysis, such as grouping them by the stock number, the stock ticker rather, and then you can do analysis such as whether there have been price spikes in the past hour or something like that based upon our buffering. So absolutely, it's something that I'm using also on the Tali project as well, server side.
Okay, we can get one more, and there are two. Okay. Where's the mic? Okay. We have two questions. Is everyone starving?
Yeah,
No?
when is lunch? Is that a question?
Yeah, lunch is after we finish talking.
Thanks for all the kittens. I'm very curious about how you handle event streams when they come in. I mean, you mentioned the callback hell and events interrupting each other.
Yep.
How do you keep track of events?
Well, what we have is like I said, the internal scheduler, which basically allows for FIFO to happen, first in, first out. So basically, you cannot have things that kind of overlap. You have them all in a queue, basically. And so as one comes in, the other one comes in. We can't necessarily guarantee order. When certain events happen, unless you use the right operator to do that. But like I said, there is no chance for an overlap. Since JavaScript's a single-threaded environment, you're not going to run into that anyways. But the idea is that it will just start merging all of these together as they happen.
Thanks.
Okay, one more question. Or we'll just keep sitting here and talking about JavaScript, because obviously no one is hungry.
And JavaScript is just that awesome.
Hi, I just want to ask that how would you compare observables to CSP in Go or Core Async and ClojureScript? Okay,
so how does observables compare to CSP? Or communicating sequential processes? Well, CSP is a very, very low-level way of dealing with I/O, for example, is the fact that you have this channel where you can start sending out values on. The problem with that approach, especially for asynchronous programming, is there is no dedicated error handling technique. There is no there are no ways of automatically cleaning up resources and all of that. So it's fine for certain aspects, but in terms of building really complex stuff, it falls down really quickly because CSP does, is because it misses the deterministic finalization and it misses the error handling components. But if you're willing to do very low-level stuff of just emitting values, CSP is fine.
Okay, well, that was really awesome QA, and I would assume that everyone is hungry, and if not, it's lunchtime anyway. We'll have, I think, an hour and a half for lunch right now, so take it slowly outside and get your food, and be mindful of your colleagues that are hungry as well. Yep, thank you, Matthew.